Hello viewers, in today's lecture we are going to take up an important property of definite integrals, and the property is related to the concept of even function and odd function, right? Now before taking this property, uh, that is integral of minus a to a f of x is equal to twice of the integral from 0 to a f of x if f is an even function, right? And in the second property, the integral from minus a to a f of x is equal to 0 if f is an odd function. So viewers, let us first see the concept of even and odd function. So what is an even function? A function is said to be an even function if the graph of the function is symmetric with respect to the y-axis, right? So what is an even function? And a function is said to be an even function if its graph is symmetric with respect to the y-axis. In other words, we can also say that a function is said to be even function if f of minus x is equal to f of x. Now, what does it mean? It means that suppose, for example, suppose we have a function fx is equal to say x square. Now if we replace x by minus x, then what will happen to this function? So f of minus x is equal to minus x square, that is plus x square, right? So this is positive x square, and positive x square is equal to f of x. So f of minus x is equal to f of x. So what is an even function? A function is said to be even function if we replace x by minus x, the function remains unchanged, right? The function remains unchanged. Let me take one more example. Suppose we have a function, say y is equal to say cos x. Now if we replace x by minus x, this is f of x, then f of minus x becomes cos of minus x. So this is cos of x, because cos of minus theta is equal to cos of theta. From trigonometry we know that cos of minus theta is equal to cos theta. So this is cos x and it is equal to f of x. So the cosine function is an even function, right? Now come to the odd function. Now what is an odd function? So a function that is symmetrical with respect to the origin, is called an odd function. In other words, a function is said to be odd if we replace x by minus x, gives us minus of f of x. Now for example, let us take y is equal to f of x is equal to sine x. Now if we replace x by minus x, then we see that f of minus x is equal to sine of minus x. This is equal to minus of sine x, because sine of minus theta is equal to minus of sine theta. So we have minus of sine x, this is minus of f of x. So therefore we can say that sine function is an odd function, right? Similarly, let us take one more example. Suppose we have a function, say cubic function x cube. Now if we replace x by minus x, we have f of minus x is equal to minus x cube. So this is minus of x cube, that is equal to minus of fx, right? So what is an even function? A function is said to be even function if it is symmetrical with respect to y-axis, or f of minus x is equal to plus of f of x. Examples are the quadratic function, and here we have the cosine function, right? Here also we can cite one more example, that is the absolute value function, right? So absolute value function is also an even function. Now what is odd function? A function which is symmetrical with respect to the origin. In other words, if f of minus x is equal to minus of fx. The examples are sine function, and we have the cubic function, and we can also have this tangent function, right? F of x is equal to tan of x. So this is also an odd function, because tan of minus x is equal to minus of tan x, right? Now viewers, let us take the graph of even function and odd function. Now suppose we have a function, say f of x is equal to x square. Now this is a function which is known as the parabolic function, the quadratic function, and its graph is like this, right? So we see that the graph is symmetrical about y-axis, right? So this is y-axis, so the graph is symmetrical to y-axis, right? Similarly, if we have the function absolute value function, f of x is equal to mod x, then the graph of absolute value function, it looks like this, and this is the graph of absolute value function, right? So here we have the graph of two functions. One is quadratic function and other is the absolute value function, and both these graphs are symmetrical about y-axis, and they satisfy f of minus x is equal to f of x, right? Okay, now come to the graph of odd function. Let us take a function, say x cube. So here we have the cubic function, and the graph of this function, it looks like this, right? So here we have the graph, it looks like this. So this is the graph of odd function, and we see that this graph is symmetrical about the origin. Clear? Let us take one more graph, that is f of x is equal to, say, sine function. Now the sine function can be plotted as, see here we have the sine function, and sine function can be plotted like this. See, this is the sine function, and here we have the graph like this. Clear? So here the graph, it looks like this. So the graph is symmetrical about the origin, right? So here we have minus pi, here we have pi, here we have 2 pi, and here we have minus 2 pi, right? So this is the graph of sine x. Clear? So the odd function satisfies f of minus x is equal to minus of f of x. Clear? Now viewers, let us take this property. Now we will prove these properties, these two properties, with the help of these graphs, and this is known as the geometrical proof of these two properties, right? So the first one is related to even function. So when we have minus a to a f of x dx, then it is equal to 2 times of 0 to a f of x. Now here I am taking this function f of x equal to x square, and let us take here say minus a, and here let us take plus a, right? So we see that this region is denoted by the area from minus a to 0 of f of x dx, and this area is denoted by area from 0 to a, right? And we write it as plus 0 to a f of x dx, right? So the area, this shaded area, is minus a to 0 f of x dx, plus then we have the area from 0 to a f of x dx. So this the sum of these two areas is from minus a to a, and here we have f of x dx, right? Now from symmetry, always remember, from symmetry we see that this area and this area are same, so therefore we can write this sum as 2 times of either this area or this area. Clear? So we have arrived at the result that the integral from minus a to a f of x dx is equal to 2 times of 0 to a f of x dx, right? Similarly, if we take this case, suppose we have to find the area from this point to this point, then see, here we have this area and here we have this area, and both the areas are equal. So therefore from minus a to a f of x dx is obviously equal to 2 times of 0 to a f of x dx, right? So again we have used the concept of symmetry. Clear? Now let us come to the second property, and we will prove this second property with the help of these two graphs. Now here see, we have to find the definite integral from minus a to a f of x dx, and it is equal to 0 if f is an odd function. So let us take this function. Now this is obviously odd. Now let us take this point and let us take this point. Now this is minus a, this is 0, and here we have plus a. Now see, this area lies below x-axis and this area lies above x-axis, and these two areas are equal but opposite in sign, because this area lies below x-axis and this area lies above x-axis. So therefore here we have from minus a to a, f of x dx is equal to, suppose this area is a and this area is minus a and this area is plus a, right? So from minus a to a, f of x dx is minus a plus a, and that is equal to 0, right? And this is due to the fact that this curve is symmetrical about the origin. Okay? Now here, if we take the sine curve and suppose we want to find this area and this area, that is from minus pi to pi. See, we want to find the area from minus pi to pi and f of x dx, right? So obviously this area is minus a and this area is plus a, because both these areas are equal but opposite in sign, because this area lies below x-axis and this area lies above x-axis. So we have minus a plus a is equal to 0, right? So always remember, if f is an even function, then minus a to a f of x dx is 2 times 0 to a f of x dx, and if f is an odd function, then we have minus a to a f of x dx is equal to 0, right? Now viewers, let us solve some problems which are based on these two properties. So here the first one is we have to evaluate the value of this integral. Let us call this integral as I. Now we see that the form of this integral is of this form, right? So this is of the form minus a to a f of x dx, and a is pi by 2 here, and f of x is equal to sine raised to 7x. Clear? Now here, if we replace x by minus x, we have f of minus x is equal to sine 7 minus x. Now this is minus of sine x raised to 7, and this is the odd power of negative sign, so we have minus sine 7x, which is equal to minus of f of x, because sine raised to 7 and x is f of x. So therefore we see that f of minus x is equal to minus of f of x. So therefore f of x is an odd function, so therefore we apply this property, so the value of this integral is 0, right? Because f is an odd function, right? Okay. Now here let us solve this integral from minus pi by 2 to pi by 2, and we have x cube sine square x dx. Now again this is f of x, we have x cube sine square x. Now if we replace x by minus x, then we have f of minus x is equal to minus x cube. Here we will substitute minus x for x, So we have minus x cube, and this is sine square of minus x. Now minus x cube is minus x cube, and sine square, because we know that sine of minus theta is minus of sine theta, so we have minus of sine x square. So this is minus square is plus, so we have minus x cube sine square x, which is equal to minus of f of x. Clear? So therefore f of x is an odd function, and by this property the value of this integral is again 0. Clear?